Okay, this question is an application question. The amount of spores produced by a particular type of fungus depends on how many days the fungus has spent in reproductive cycle of its life. So they've shown the fungus A starts by producing 1,000 spores, but in 2 days it produces 3,062 spores. The number of spores can be modeled by this equation, where P is the number of spores produced by fungus A after T days. Sorry. So, first thing it's asking us to do is to show that K equals that value. The next thing it's asking us to do is to show that, is to work out how long it's going to take to reach 20,000. What we're going to do B first. We're going to use this value of K. And I do that because I'm just substituting in some values. So let's see how that goes. So basically what we want to see with this is we want to see you writing down what I'm about to type. So we'll say 20,000 equals 1,000 times 10 to the power of, not that one, sorry, 1,000 to the power of 0.234, 0.234, 0.234, 243, sorry, 43. So that's what multiplied by t. That's what we want to see you writing down. We want to see something like that. And then what we're going to do, we're going to solve that for t. So we're going to say solve, because what we want to see is that you know what to let your equation equal. So we're solving that for t. So you write down this line. I wouldn't be writing down this line. That's weird. Write down this line because that's what you're actually solving for. And then we're going to work it out. We're going to say t equals 5.35. So how many days to 2 decimal places will it take fungus to be capable of producing at least 20,000 spores? So 5.35 days. Okay, now, how do we solve for K? We're going to show that K equals that. Well, we've got to use some of this information here, specifically this 1,000 spores and this 3,062 spores. What I think we'll do is we'll set up simultaneous equations, but we'll see. So what we're going to do is we are going to define PA of T. We have to graph it. I'm just checking if we graph it. Don't have to graph it, we can just leave it as T. Sketch that down. We've got to, okay, cool. We've got to graph it. Okay, so define PA of X. I'm saying PA because that's simply what it is there. Equals this, except I'm going to write K. Oh no, I need that to be an X. And I'm given a domain 0 to T, 0 to 7. So I'm going to say, whoops, where 0 is less than or equal to X, less than or equal to, yeah, which is also then less than or equal to 7. Okay, so I've got that. So now what I'm going to, oops, no, we don't want that. Oh no, did I make a mistake here? Yes, I did. Damn. Okay. We're going to redefine this. It's not equals. So we're going to remove this. I'm just going to keep this part. So I made a mistake there. I included this. I shouldn't have done it. It should just be 1,000. It should just be this part of the equation. I wonder if anyone picked that up. Anyhow, that's what we've got there. So now what it tells us is that at 0 days initially, 1,000 spores. So we're going to say that, and then after 2 days, it's 3,602. So what we're going to do, we're going to say solve. That should be easy enough. So we're going to solve PA of X equals 3062. 3062. Except we're not saying 3. Damn, I can't type in 6. 3062. Except we are saying this is 2 days. So I'm going to leave that as it is. I'm going to solve that for K. Alright, so what I'd be expecting is for you guys to write down that 1,000 times 10 to the power of start it again. Keep pressing the wrong thing. To the power of k times 2 equals 3062. 30. Done it again. 3062 is what you've got there, and then we're going to solve that for k. We end up with that thing there. I'm going to say 0.0, and we end up with their answer. So this is the type of thing I expect to see. That's what you're solving for. So you'd write that down, and you go off and you show that it's what it is. Okay, second species of fungus B also shows exponential increase. It can be started with 5,000 spores. 2 days produces 71, so the value of C equals 2. So we're going to go through the same thing. But like it says, sketch the graphs, labeling any points of intersection. So we'll do that. So we're gonna define this. Tell us what C is. Tell us that C is 2. So that's what we're going to do. So we're going to say define, make a new function, define PB of X equals 5,000 times 2 to the power of, no, wrong one, to the power of 0.25x. Okay, once again, given the domain of 0 less than x less than 7. That's what we've got there. Now we will graph them both. A x. A lot of okay, damn it. I will redefine that function because I left the k there. So we know that k is 0.24. Just check it. That's what I'm told in the question. 0.243. 243. So if I go to this, we're graphing PA of X, and we're going to say window settings. We're going from say -1. We're going to 8, so we can see what's going on. We're going from -10 to, we'll go to 6,000, 7,000. So that's what's showing us there. And we'll do the second one. PB of X. Oh, that's what we've got going on there. Let's have a look. So we need to zoom out some more. Window settings. Tab. Let's go out to say 17,000 just because it's a bit quicker. And there we have our graphs. Going to go a little bit further. So that's just to sketch the graph. So window settings. Let's go to 27,000. Still not enough. I'm trying to see exactly where this one ends. So what we'll do, we'll go back to this. We'll say PB of 7. And we're at 16,000. That's odd. Clearly I've gone well above. Oh no, PA is the higher one. Oh, okay. PA of 7. 50,000. So let's go up to 52,000 or 51,000. Menu, window, 51. So there we have our two graphs. Now, the reason I've done that is because it says sketch them, labeling models, endpoints, and points of intersection. So I've got that. So I'm going to label my analyze graph intersection, that graph and that graph. That's it. So that's my point of intersection. And then I'm going to say, okay, so we can get our endpoints from this information here. PBS7 is that, so that's the endpoint. So 16,000. So our endpoint is, whatever, we just do the maximum. So menu, analyze graph, maximum for that graph left. We are at 7 and 5,000 or 50,000, but we got that before. 750,234. Go back to the other one. Menu, analyze graph, maximum. Here we are at 7 and 16,000 or thereabouts. 16,817. So that's what we'll be putting in there. For the other endpoint, we know that they both happen at 0. So what we do is we can go analyze graph, minimum for that graph, there and there, happens at 1 and 3,000. Sorry, it happens 0 and 1,000. And our last graph, minimum, this should be 5,000. Yeah, 0 and 5,000. That's what we end up with there. Remember to label them properly as well. Okay. So show that the value, now we're going to go back and do this and show the value of c equals 2. So what we're going to do, I'm going to go back over here. We're going to say PB of x. That's what we've got there. So now we're showing that that thing equals 2. So what we're going to do, going to type in look at my equation. So this is what I'd be writing down. I'd be writing down 5,000 times c to the power of 0.25. Sorry, yep. T. That's my equation. 0.25 t equals 7071. 7071. And I know that happens at times 2. So I'd be writing this line, and then I'd say solve. We're solving that for C, and we get 1.99996 or something like that. So that's what I'd be writing this line and then saying C equals that, and then C equals 2. Okay, last question. When do the two models predict the same number of spores? Give you answer 0.01 of a day. State the number of spores at this time, 3 decimal places. Now, if we have a look at our graph, it goes, that's where they intersect 0.1, sorry, at 4.17. Now, the problem is it's telling us that we're not quite getting the right answer. We're not quite getting what they're after. They want to know 0.1 of a day. We're getting that, 4.17. And then we want the number of spores at that time. This isn't really the number of spores. So what we do is we say PA 4.17. And we have at 10,311. Well, it wants to go to 3 decimal places. Okay, that's going to be a little bit harder. So what we've got to do, we've got to solve PA of x equals PB of x. We're solving that for x. And there we have, that's our value there. More solution may exist. That's fine. That's because of the domains. All right, so what we're going to do now, we're going to say PA of this value. I'm going to delete the x. We're at, so that's what we've got, 10,293.479. That's what we'll be looking at there. So that's the way we go about answering that question. Alternatively, this might work. Because we've done that, we may be able to put that in, sorry. Because we've put this in, we may be able to just look at this, and here we can get 3, 2, 0. 10,311.219 would be that. So I would have to accept either one.